Good morning students, let us discuss about interhalogen compounds. So here interhalogen compounds. Interhalogen compounds is nothing but what here the halogens itself only will form the compound. Means no extra element will come and add here. So means here when two different halogens react with each other, when two different halogens react with each other, then what will happen? Interhalogen compounds will be formed. What happens? When two different halogens react with each other, interhalogen compounds are formed. Okay, so here we are having different types of interhalogens, that is XX dash, XX dash 3, XX dash 4, 5 and XX dash 7. So where here X is equals to means what? Halogen of large size. Okay, so means what here? The halogen is having large size with more electropositive nature. So it is having electropositivity more and also the size will be also more. Coming to here X dash, here it is having halogens of small size with less electropositive or more electronegative nature. So this is, so whenever you are taking two halogens, one halogen should have large size, another halogen should have small size. Okay, so this is the meaning of this. And coming to here, the ratio between radii of X and X dash increases and the number of atoms per molecule also increases. Whenever the ratio between X and X dash is going to increase, means what here? As the ratio between radii of X and X dash increases, the number of atoms per molecule also increases. Okay, so whenever the ratio between, so the X by X dash is increasing, so for example the radii is equals to here X by X dash. So whenever it is increasing the ratio of this one, and also whenever you are taking atoms of molecules also is going to increase. So that is the meaning of this point. And also here iodine, it is having, which is a 7th group element, it will have maximum number of atoms. So between the ratio of iodine and F should be maximum here. So that is why its formula is IF7. So some atoms will be not having the structure. XX dash, the formula is IF7. Okay, so here the ratio of radii for iodine and fluorine is maximum, means what here? More increases. So that's why the structure is forming the IF7 with maximum number of atoms. So that's why what happens? So the number of atoms will be forming. Okay, so now let us see about preparations. Preparation of halogen compounds. So preparation, let us discuss about preparation of halogen compounds. So here the interhalogen compounds can be prepared by direct combination or by the halogen and lower interhalogen compounds. Okay, so it depends upon some conditions. So let us take for example Cl2 F2 temperature 473 Kelvin, you will be getting 2ClF. So this is one of the preparation. And also I2 plus 3Cl2. When you are taking more as a chlorine, so you will be getting here 2iCl3 and also Cl2 plus 3F2, which is in excess. So here also at 573 Kelvin you will be getting 2ClF3 and also here Br2 plus 3F2. This F2 is diluted with water. So here you will be getting 2Br F3, I2 plus Cl2, which is in equimolar, it will be getting 2iCl, Br2 plus 5F2, it will be getting 2Br F5. Okay, so here what will happen, what is the so generally what I have told you definition, when two different halogens react to form a compound, that is interhalogen compound. So here what we are taking, two different halogen, this is having more size, this is having very less size, if you have been observed. So means what here, these are the preparations under certain conditions it is forming. Okay, so we are having some of the properties means in diagrammatic manner. So here let us take the type. Here formula, here physical state and color, so here structure. Okay, so now let us discuss about this, some of the properties here. So here what will happen, so let us take XX dash. Okay, so here XX dash 1 we are taking, the formula will be here ClF, BrF and IF. These three are the compounds forming with this one. So here this ClF will be having colorless gas. Okay, BrF will be having here pale brown color gas. Coming to IF, it is going to have spectroscopically it is unstable, we can say. It will not exhibit any color. So simply we can say what is the property here, spectroscopically unstable gas, we can say it is not having any structures. And coming to here, if you take BrCl, it will be having ruby red solid, which is will be in alpha form. It is in alpha form. If you take ICl, it is brown red solid, which is in beta form. And coming to IBr, it is a black color solid. Okay, these nothing will be having the colors. So this is what here XX1. So what are the examples we have taken? ClF, BrF, IF, BrCl, ICl, IBr. So some will be having colors, some will not be having the colors. Okay. So now let us see next one. So X3. Okay. So here we are having ClF3. ClF3, it is a colorless gas with a T-shaped, we can say. So generally the structure will be how means bent shape, we can say. And coming to BrF3 also same. It is a yellow color, yellow green with T shape, yellow green liquid actually. So it is having bent T shape structure. And coming to here IF3, it is having color yellow powder. This is also having same. So whenever you are taking 3 means it is automatically having the same structure, that is T-shaped structure we are having. So here what will be having bent, here also T shape. If you take ICl3, okay, so this will be having orange solid color. So it is also having bent T shape structure. So how will be the structure here? For example, if you are taking ClF3, like this you are having. Okay, so F. How it is a T shape with a 2 lone pair of electrons. Like this you are going to have this structure. Okay, if you take any molecule like this only, it is going to exhibit the structure. Next, coming to here XX5 dash. So what are the examples here? We can take IF5. Okay, so it is a colorless gas, we can say, but solid. It will become solid below 77 Kelvin. Okay, so the shape will be here square pyramid. What will be the shape here? We are having square pyramid. And also if you take example BrF5, it is also colorless gas. It is also having shape square pyramid. And coming to if you have been taking ClF5, it is also colorless gas. It is also having square pyramid. So means what here? If you have been taking ClF5, 1, 2, 3, 4, 5. So pyramid means what? 1 lone pair of electron you will be having. So square pyramid structure you are having. So this is about the examples of the XX5 dash. And coming to XX7 dash, it will form only compound, that is IF7, so which is a colorless gas. This is also, so maximum halogens will form the gases only which will be in colorless. So here we are getting a pentagonal bipyramidal structure. Pentagonal bipyramidal structure. So the structure will be like this here. I, F, 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 here F, here F, 1 lone pair of electron you are going to have. So this is the pentagonal bipyramidal structure. Okay, so this is about the examples and structures and properties we are going to have. So generally here there will be some properties we are going to have, that is what means here the pure solid of BrCl means what here. If you take BrCl, it is a pure solid, very pure solid. So whenever you take here the pure solid of BrCl is at room temperature, will be known at room temperature only. We will be knowing it is a BrCl is a pure solid. So these all, whenever you take here ICl3 dimerizaceous means what here, as Cl bridge dimer, so means what here, Cl6I2 it will form. So like this it will be forming II. So here Cl, 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 Cl. So means what, it is a bridge type of compounds it is going to form. So these type of compounds, what we call is this ICl2 dimerizes as a Cl bridged dimerase. And also these are all covalent compounds, we can say. These are all covalent molecules. Why? Because they itself only it will be forming shared pair of electrons, and all are is in diamagnetic nature. Diamagnetic nature. Why it is diamagnetic nature is nothing but here it will be completely repel, means what, it will be having complete pair of electrons. Because of this reason it is a diamagnetic, and they itself will form the covalent molecules, means what, shared pair of electrons they can form. And also they are volatile solids. Volatile solids or liquids, except CLF, which is gas at 298 Kelvin. So means what here, volatile solids means what, volatile solids are liquid which can easily evaporate. Those type of compounds we call it as volatile solids, except CLF. Why? Because CLF is a gas. So because of that reason it is not a volatile compound. Remaining all, whatever you are taking halogens, this will be remaining volatile compounds. Okay, so here the physical properties are intermediate between the halogens and of their melting point, which is having higher than expected. Okay, so generally interhalogen compounds are more reactive than halogens, we can say. Why? Because except fluorine. Why? Because here XX dash bond in interhalogen compounds is weaker bond in halogens except FF bond. So what we can say here, interhalogen compounds are more reactive than halogens except fluorine. Why we are saying more reactive? Why? Because XX dash bond, when you are taking bond in interhalogen compound, okay, in interhalogens is weaker than XX bond in halogens except fluorine. Okay, so when you take ClCl, it is very weak compared to XX dash bond. So because of this reason only we are saying these type of compounds are very reactive. Okay, so all these interhalogens will undergo hydrolysis. It will give halide ion from this smaller halogen, and it form a hypohalate, halate, halate and perhalate. Like this it will be forming. Okay, means what will happen, they will form some derivatives. So means what here, whenever you treat with XX dash plus H2O, it will form what, halides, hydrogen halides it is forming. And also here what will be, water HOX it is forming, it may be hypohalate, Okay, hypohalate is means XX dash, or halate it may form means what here, XX dash 3. So or else we can form halate, that is XX dash 5, and perhalate, that is XX dash 7. So like this it may form. When you're treating with water molecule, it is forming a anions here. Okay, and also you are having some of the uses. Interhalogen compounds are used as good fluorinating agents. Why as a good fluorinating agents means for the production of UF6 in the and the U235 it is used. Means for example, if you have been taking here ClF3, BrF3 are used for the production of UF6 in the uranium 235. U is nothing but uranium here. Okay, and also here we'll be having different types of structures for this XX3 dash, XX5 dash, and XX dash 7. So it will be having the hybridization is sp3d hybridization, it is a central atom, and coming to here sp3d2 hybridization, it is having sp3dt hybridization. So these are nothing but the uses we can say here. So this is nothing but interhalogen compounds. In the next topic we can discuss about group 18 elements. Thank you.